AOPS Volume 1, the basics, number 93. Find the units digit of 3 raised to the 1986 power minus 2 raised to the 1986 power. So let's write that down. 3 raised to the 1986 minus 2 raised to the 1986. And as I've stated in previous videos, always look for the patterns of alternating units digits to find a pattern. Because remember, any number raised to any power, such as 27 raised to the 1 millionth power, to be extreme, always has a alternating sequence, if you will, for the units digit place value. And all I need to do is find the subtraction of the units digit of this number with this number's units digit, and that will give us our answer. Because we don't really care about the rest of the numbers, because only the subtraction of the units digit will give us the units digit of this subtraction. So let us begin. So what is 3 raised to the first power? The units digit will have a digit of 3. And 3 squared will be equal to 9 with a units digit of 9. 3 cubed will be equal to 9 times 3 with a units digit of 7. And 3 raised to the fourth power will be equal to 9 times 9, which is equal to 81 with a units digit of 1. And from here, the pattern will cycle through. What is 3 to the fifth power? That is equal to 81 times 3 with a units digit of 3. 3 to the sixth power will be equal to 81 times 3 times 3 with a units digit of 9. So you see here that this pattern exists. And this pattern exists for all numbers. 7, 7 squared, 7 cubed, 8, 9, 8, 9, 7, 3, 5, 2, whatever you want. This only exists, by the way, for only single digit integers. Note, only single digit integers will have a alternating and a pattern within its units digit. In multi-digit numbers, that just boils down to the same logic, that the units digit, no matter what number, will have a alternating units digit. So with this conclusion, we know that we can find the units digit when 3 is raised to the 1986th power. And what can we deduce from the power? Well, we can first divide 1986 by 4. And the reason why I'm dividing this by 4 is because for each 4 multiples of 3, we have a series. So divided by 4 will give us how many series have passed before we have a remainder. So this becomes 16, 38, let's see, 9, 36, 26, and put 6, we have a remainder of 2. So 496 series of 3 to the first power, 3 to the second power, 3 to the third power, 3 to the fourth power with units digit 3971 have passed before we are left with 2. So what are 2 going down from our list of series? 3 then goes to 9. So the units digit of 3 raised to the 1986 power must have a units digit of 9. And now we're almost done with this question. What is 2 raised to the 1986 power? Well, same logic. 2 to the first power, units digit 2. 2 squared, units digit 4. What is 2 cubed? Units digit of 8. And 2 to the fourth power, which is a unit digit of 6. And from here, it repeats. 2 to the fifth power will be equal to 16 times 2, units digit of 2, and so on, etc. So dividing 1986 by 4, we get 496 remainder 2, meaning that 496 of the series with respect to 2 now have passed with a unit digit of 2486. And then we are left with 2 more, so we have to go down from our series from units digit of 2 to the units digit of 4. Hence, the units digit of 2 raised to the 1986 power will be equal to 4. And what is 9 minus 4? That will be a grand total of 5, which is the solution to this question. And you might be seeing a pattern here. And it's always good, generally, within mathematics to always deduce patterns, because that is all that math is about. And for every 4 multiples of 3, 3 to first power, 3 squared, 3 cubed, 3 to the fourth power, 2 to the first power, 2 squared, 2 cubed, 2 to the fourth power, will then alternate. And this applies for every single number except to some certain few. But nonetheless, the solution to this question will be 5, and the solution to this question